Okay, welcome viewers. So, in the last video lecture, we saw this thing that how to use modular arithmetics. Okay, now in this video lecture, we want to talk about a Euclidean algorithm. In the previous video, we also found GCD and LCM of given numbers. A Euclidean algorithm is also used for finding GCD of numbers. Okay, and this method is basically used when numbers they are big numbers. Okay, and this method is very efficient. Okay, and it gives you answer very quickly. So that is why we use this method for finding the GCD of two numbers. Okay, so to show you that how to solve the question using a Euclidean algorithm, so suppose we take this example that find the GCD of 16 and 25. Okay, we want to check that what is the GCD of 16 and 25. So see here clearly 16 is less than 25. Okay, so what you do, you divide 16 sorry, you divide 25 by 16. Okay, divide 25 by 16. So 16 ones are 16. What is the remainder here? The remainder here is 9. Okay, now you check this remainder. Okay, this remainder it is less than this previous divisor. Okay, so if this remainder it is less than your previous divisor, okay, which is this 16, what you do, you take then the previous divisor it becomes dividend next time, and this remainder it becomes divisor this time. Okay, so 9 ones are 9. Okay, so you see that what do you get here? 16 minus 9, it is 7. So this remainder it is less than previous divisor. Okay, so now this becomes divisor in the next uh, portion. Okay, and this previous divisor it becomes dividend. Okay, now further we divide 9 by 7. So what do we get? 7 ones are 7. Okay, so 9 minus 7 is 2. Okay, now next time this previous remainder it becomes dividend. Okay, so 2 threes are what? 6. Okay, 2 threes are 6. So in the end what do you get here? 7 minus 6 it is 1. Okay, so this now becomes the divisor, and the previous divisor it becomes the dividend. Okay, so 1 2s are 2. Okay, so you see that this last remainder, okay, this last remainder, okay, this is called uh, HCF of these given numbers. Okay, so HCF, or you can say GCD, one and the same thing. GCD of 16 and 25, it is equal to 1. It is equal to 1. So this is how we use a Euclidean algorithm for finding the GCD. Okay, we solve one more example. Okay, give you better idea about this thing. Okay. So see the next problem. So the next problem is this: find GCD of 287 and 91. Okay. So now what you do, you clearly see here that as 91, it is less than 287. So this 287, it becomes dividend. Okay. And this 91, it becomes divisor. Okay. So now you check that what is 91 into 3. Okay. 91 into 3, it gives me 273. Okay. Now you subtract uh, 273 from 287. So 287 minus 273, it gives you 40. Okay. So see this remainder. Okay, this remainder, it is less than previous divisor. Okay. So this now becomes divisor. Okay, in the next step, and the previous divisor, it becomes dividend. Okay. Now next you see that what is 14 into 6, what it is. 14 into 6 is 84. Okay. It is 84. Now what is 91 minus 84? It is 7. Okay. And now your previous divisor, it now becomes dividend. So 7 twos are 14. So see in the end uh, you get 0. Okay. So what is the last remainder? Okay, last remainder is 7. Okay, I just highlight it. This is the last remainder. This is the last remainder. Okay. So whatever is your last remainder, that is taken as the GCD. Okay. So GCD of 287 and 91, it is what? It is 7. Okay. I hope that this process, it is clear to you, that how to find the GCD of two numbers. Okay. Now we solve this problem uh, for one more question. We apply this method for one more question. So the question is this: that find the GCD of 414 and 662. Okay. So now you see that clearly 414, it is less than 662. So divide 414, sorry, 662 by 414. Okay. So 414 into 1. Okay. Uh, it is 414. What is the remainder here? Once you subtract 414 from 662, you get the remainder as 248. Okay. So now as this 248, it is less than your previous divisor. So now this previous divisor now becomes dividend. Okay. Now next 248 into 1 is 248. Okay. And what is the remainder here? The remainder here is 166. Okay. Now divide 248 by 166. Okay. So 166 into 1 is 166. Okay, and what do you get here? What do you get here? See, on subtracting 166 from 248, we get here 82. Okay, now clearly this 82, it is less than the previous divisor. Okay, so now this previous divisor now becomes dividend. Okay, so 82 into 2, 82 into 2, it is 164. Now 166 minus 164, it is what, 2. Okay, and it is what, 82. Now 82 into 41. So here you get 0 in the end. Okay, so this last remainder, okay, this last remainder, this is called the HCF. Okay, so the HCF of given number 662 and 414, it is just equal to. Okay, so I hope you people have learned this art, that how to find the HCF. If you are still facing any issue, then you watch the video once again. Okay, uh, so that you may learn it in a better way. Okay, but what I do, I solve one more question for you people. So question is this: find GCD of 12 and 18. 12 and 18. So clearly 18 is bigger than 12. So divide 18 by 12. Okay. So 12 ones are 12. What is the remainder? 18 minus 12, it is 6. Okay. And the previous divisor, it becomes dividend here. So 16 twos are 12. Okay. So you see that this number, okay, this number, the last remainder, it is called the GCD of these two given numbers. Okay. So GCD of 12 and 18, it is what? It is 6. So you see that how easy it is to solve the problem using a Euclidean algorithm. Okay, but next we want to learn about this art, that how to write our GCD as a linear combination of given numbers. Okay, so see this result. Result is this, that this is actually a theorem. Okay, and the statement of this theorem is this, that if A and B are positive integers, okay, then there exist then there exist integers S and T such that GCD of A and B, mean whatever is the GCD of A and B, that can be written as S into A plus T into B. Okay, and A and B, they were the given numbers. Okay, and S and T, they are the integers. Okay, so you see that we have expressed our GCD as a linear combination of given numbers. Okay, here these numbers S and T. Okay, here S and T, are called Bezout's coefficients. Okay, these are called Bezout's coefficients. Okay, S and T are called Bezout's coefficients. Okay, so now we solve one example. Okay, for finding the Bezout's coefficient. Okay, so see, I repeat this problem once again. That find GCD of 287 and 91. Okay, so clearly 91, it is less than 287. So divide 287 by 91. Okay, so 91 into 3. Okay, 91 into 3. What it is? It is 273. Okay, it is 273. Now 287 minus 273. What it is? It is 14. Okay, it is 14. Now divide your previous divisor 91 by 14. Okay, so 14 14 into 7, for 14 into 7, it is 98, but 14 into 6, okay, 14 into 6, it is 84. 14 6 84. Okay, now 91 minus 84, it is what? It is 7. Okay, and then uh, the previous divisor, which is 14, you divide it by 7. Okay, so 7 to the 40. Okay, now you see that here in the end we are getting the remainder 0. So the last remainder, okay, the last remainder, it is the GCD. Okay, so GCD GCD of 287 and 91, it is what? It is 7. Okay, now we also know this thing, that whenever we perform division, then by uh, division algorithm, okay, we can write this dividend, which is 287, as divisor into quotient, okay, 91 into 3 plus remainder plus 40. So write it as equation number. Okay, now for the next step, again write it in the same manner. So 91, which is the dividend, it is equal to divisor, which is 14, into quotient, which is 6, plus remainder. Okay, now the last one is 14. 14, it is equal to 7 into 2. Okay, here the remainder is what? It is 0. Okay, so write it as equation number 3. Okay, you leave this equation where you are getting remainder 0 and start from the equation which is just behind it. Okay, so start from this equation, which is equation number 2. This is your GCD. This 7 is your GCD. Now what you do, we want to express this GCD as a linear combination of our given numbers, and our given numbers, they were 287 and 91. Okay, so write this 7 as from 2. Write this 7 as 91 minus 14 times 6. Okay, you bring this 14 into 6 to this side, so it becomes 91 minus 14 into 6. Okay, now check what is the value of the previous remainder. Previous remainder is 14. Okay, previous remainder is 14. Now from this equation, okay, delete this 14. Okay, so how can we delete this 14? By substituting the value of 14. Okay, so 14, it is equal to 287, okay, minus 91 into 3, and outside it you have 6. Okay, I substituted the value of 14 to delete it. So 14, it is equal to 287 minus 91 into 3. Okay, so what it is 91 minus 287 into 6. Okay, minus minus plus, so it is 91, 3 into 6, what it is 18. Okay, and here what is the coefficient here is 1. So 1 plus 18, it is what? It is 19. 19 into 91 plus 287 into minus 6. Okay, so you see that what are your given numbers. My given numbers in this question are 91. So write 91 and take this other number as S. Okay, other number is 87, 287, and write this another number as T. Okay, so S value it is 19, and T value it is minus 6. Okay, so S and T, these are Bezout's coefficients. Okay, these are Bezout's coefficients. I hope that you have no doubt in this. Okay, but we solve one more question. Okay, so that you understand it in a better way, that how to solve these types of problems. So the question is this. Let me write this problem. So the problem is this, that express g.c.d of 252 and 198, which is equal to 18, as a linear combination of 252 and 198. So it is a very easy problem. Solution: clearly 198, it is less than 252. So divide 252 by 198. Okay, so 1 into 198 is 198. Now what is the remainder here? Remainder here is 54. Okay, so your previous divisor, it now becomes dividend. Now 54 into 3. Okay, 54 into 3, it is equal to 162. Okay, now we subtract 162 from 198. So what is the answer? Answer is 36. So this remainder now becomes divisor, and the previous divisor, it becomes dividend. Okay, so 36 ones are 36. Okay, so 54 minus 36, what it is? It is 18. And here the previous divisor, okay, it now becomes the dividend. So 18 twos are 36. Now now from in the beginning, we can write this 252, which is dividend, as divisor into quotient. Quotient is 1 plus the remainder. Okay, so this is equation number 1. Now next is 198, which is dividend. In this case, dividend is equal to divisor into quotient plus remainder. Okay, write it as equation number 2. Then again 54, this is equal to divisor into quotient plus remainder. Okay, write it as equation number 3. And you see the last one is 36, which is equal to 18 into 2. And here this value is 0. So write it as 4. You were told in the previous question also that you leave uh, the equation where you get the remainder 0 and start from this previous equation. Okay, so here 18 is the GCD, so we can write 18 from 3 we can write 18 as 54 minus 36 into 1. Okay, now check what is the previous remainder. Previous remainder is 36. Okay, so from this equation, okay, uh, you delete this 36 by substituting this value of 36. Okay, so 36, it can be expressed as 198 minus 54 into 3, and outside it you have 1. Okay, so this can be written as 54 minus 198 minus minus plus 54 into 3. Okay, so here what is the coefficient of 54? It is 1. Here it is 3 and here it is 1. So 1 plus 3, it is what? It is 4. 4 times 54 minus 198. 198. Okay, so now what we do? What what we do? We just substitute the value of previous remainder, which is 54. Okay, so it is 4 times 54. It can be written as 252 minus 198 into 1 minus 198. Okay, so this then becomes, see here, uh, we can write it as, we can write it as 4 into 252 minus 198 into 4 minus 198. So 4 into 252 minus, here it is minus 4 and here you can introduce 1. So minus 4 minus 1 is what it is, minus 5 into 198. Okay, so 4 times 252 plus 198 into minus 5. So this can be written as 252 into S plus 198 into T. Okay, so this is how we can write our GCD as a linear combination of the given numbers. So what is the S value? S value is 4 and T value, it is what? It is minus 5. So these are our Bezout's coefficients. Okay, so thank you very much viewers for watching this video. More about the number theory will be discussed in the next video lecture.